Okie dokie. So, welcome to the new episode of That IT Show podcast. Today we are continuing on the topic of DevOps a little bit, which we covered a part of in one of the previous episodes. We are going to specifically talk about containerization technologies, and specifically use case that we're going to be discussing today is going to be related to, let's say, a scenario in which we are discussing containerization of monolithic applications. So how to containerize what we usually refer to as monolith and how that can be done, what needs to be done for that to happen, and how we are going to operate and manage that application in the future in the case of us doing a successful containerization, let's say, project. With that being said, so welcome to That IT Show podcast, where talk meets tech and vice versa. And let's roll the intro. Okay. You have questions, or should I start? Do you have some difficult topics that you want to cover at the beginning?
Yes.
Go ahead.
Is there any reason why we should abandon monoliths and move to Dockers or containers?
There might be some, but they are, I think, rare, much more rare than what the technical marketing or marketing lets you believe.
Okay, and the other one is containerization in principle faster than monoliths?
If the design of the application is correct, if we are talking about scale out, there is a big chance for the application to be faster, but it heavily depends on the architecture.
And I think, I'm completely fine with
either answer.
Either answer or both answers. But I think that the thing that we are forgetting is also the actual usage case.
Of course.
Because if you redesign or over-design the...
refactor.
If you over-design the architecture, you're going to end up with an amazing architecture that can scale up, but is never going to be scaling up. So you are wasting resources to refactor the code, to redesign the application without any actual meaning or gain.
Thank you for saying that out loud, because that's actually my pet peeve. That's the reason why I wanted us to do this episode, because I already mentioned more than a few times in previous episodes, I'm more of a cloud realist than a cloud big enthusiast. There are really business-related, technical, and rational reasons behind that. And I find the way in which the Docker, Podman, containerization, Kubernetes, OpenShift, whatnot, basically technical agenda being shoved down our throats is completely useless and way off base. Because there are applications, and there are many applications that we can spend from now to eternity trying to containerize them, and we're going to get absolutely nothing out of it.
Okay, we are going to get, the thing that we are going to get out of it is contract hours. So the only thing that...
Let's say that that's not the topic of this podcast time.
Yes, but I think sometimes that this is the only reason why people are dealing with containers.
You're absolutely on point.
Because sometimes when I see some of the solutions, I think that one of the most important applications that should be ported into a container should be Clipper. Having a Clipper running in a container as a single user in a single user application would probably be the most important application for a lot of cases.
Because there are thousands and thousands of Clipper-based applications which could then run in containers.
Yes, and this is one thing, and the other thing is that running.
What the hell did I do to you today for you to become so insanely crazy?
I think that the problem is that what I'm trying to say is that. A reason behind redesigning and over-designing things is that sometimes We are trying to solve a problem of crashing a nut with a bulldozer.
By using a bulldozer or a tank.
By using a
Yeah.
bulldozer. Sometimes a simple Visual Basic application running in a Docker, or a simple Visual Basic application running by itself, or a statically linked application in Linux is good enough to solve a problem. We don't need to have a multi-platform
Multi-architecture.
lambda serverless based architecture that is going to be communicating over protected channels and HTTPS and whatever not. It just sometimes, and I think most of the time, we are just complicating.
Are you basically talking about over design from the perspective of people doing over design for over designing reasons?
I think that we should first start from the developer standpoint. A lot of developers...
Because there is a reason why I asked you this question before we go there. Because if I'm being realistic and self-critical, I'm definitely prone to thinking like that in many occasions. Let's say sound design and stuff like that. And you commented on this many, many times. So I understand the impulse for certain things, not for everything, of course. So feel free to use a hammer to hammer that point home whenever I say something stupid today.
I think that the idea, my idea behind all of this is exactly the hammer. Because when everything, or the only thing that you have a hammer, everything looks like a nail. So this is one of those problems where a developer
Without the problem.
Is he has a solution and then he tries to fit the problem to the solution.
Yeah, solution without a problem.
No, a solution and a problem, but the solution should fit the problem, not problem should the problem shouldn't be fitting a solution. But sometimes some of the solutions are created in such a way that the problem should be part of it. So this is one of those things when sometimes I think that a lot of the problems come out of a developer not understanding the problem, having a limited amount of knowledge about how this problem can be solved in different ways.
From technical standpoint. Okay.
And then having too much knowledge about a particular architecture and not enough knowledge about any other architecture, and then just fitting whatever he knows into how the problem should be solved. And this is one of those things that is, from my perspective, normal when you think about human beings, but enormously wasteful when you think about solutions.
Okay. Sounds reasonable.
Okay.
What's happened to you?
No, I'm just making a point.
Shorter hair brings the reasonable dude in you or something?
I'm just testing testing an edge case.
Edge case. That's cool. Okay. So basically, in the past couple of years, I've been dealing with dozens and dozens and dozens of either custom or mostly VMware courses related to containerization. Both, let's say, basic level and much more advanced, because VMware developed a huge load of different apps and concepts, albeit being very late to the market. Let's be honest about that as well. That should cover any kind of enterprise use case for containerization. And they did it really well, actually, because the UIs that they have are incredible. I think that both you and I agree that the UIs for managing, let's say, larger Kubernetes or OpenShift-based installations are not necessarily very good from most of the manufacturers, borderline useless in a lot of the use cases. So that's the first thing. The second thing is that because of my PhD work, I've been involved heavily in some stuff related to Kubernetes. And I have prior experience of working with it and with OpenShift, and I appreciate all of those orchestration / scale out mechanisms that you can implement, and all of that is beautiful and sounds very good as a part of the story that you can tell a developer or some kind of Excel IT manager or whatnot. But the second part of that actual reality, not the virtual reality, is the fact that there are many applications that have no business being containerized. Your example with, what was it? It wasn't Delphi, it was...
Clipper.
Okay, Clipper, Delphi, whatever it is. was actually right on point, and cloud in general can be kind of used for that metaphor, because in general, a lot of people tend to think about cloud as a solution for a certain problem, but in exactly the way in which you described it, basically solution without a problem. And there are so many different types of workloads that you cannot really cover in cloud correctly, and that kind of just comes full circle when you start dealing with containerization. The starting point of this discussion is exactly the right question that you asked, which is, do we need to containerize the monoliths? I think that merits further analysis. And if we do, basically we can ask a certain set of questions, like why should we containerize the monolith if it works well? The answer to that question might be, if the architecture is good enough and if it can be containerized for the purpose of actually gaining additional performance, then it kind of makes sense. But not from the standpoint of a metaphor that I was giving. Designing for design reasons only and to future-proof and be ready for the future and whatnot, which is what I did with certain pieces of equipment that we use. And you commented on this privately, and you were completely correct. We have too many cameras and we don't use most of them, just as an example. When you apply that thought process to the process of redesigning, refactoring applications, you get to the very same results. You're basically trying to figure out the way to look smart for the purpose of looking smart, if and when a certain scenario happens for you in the future. And if that's the basic reason why you are doing the containerization, then that reason is not good enough.
But yes, but I am with you on most of it. But my main thing is that, for example, when you're talking about cameras, I considered the part about the cameras as something that can be called research and development.
Exactly the way in which I'm treating it as well.
And this is something.
It's always a learning opportunity.
Yes, and this is a learning opportunity. This is one thing, and the other thing is that you need to learn something. You have spare parts, that's okay. But the idea of pushing a large number of cameras on without having any additional benefit out of it would be stupid.
Hence my metaphor for containers.
And the problem with containers is that sometimes people are doing extremely stupid things. They are trying to refactor or reparse the monoliths into different containers or serverless. I like the serverless idea right now.
As if that exists.
Yes, it's nobody's computer.
Yeah, sure.
So if the cloud is other people's computer, the serverless is nobody's computer. But I like the idea of having something that is being reparsed and being refactored just for the sake of the intellectual exercise. And
not a production application.
Yes, not a production application.
Okay.
And this is something that I'm going to do a couple of references today. First of the references, I think that everybody who is into trying to design something should be reading two books. One book is Mythical Man Month, and the other is Systematics, the Theory of the Systems. Both of those books are old enough to be older than me. So they were written somewhere in the beginning of 70s. And both of those books are trying to explain in a particularly, I would say, amusing way, how the big systems work. And I think that people should start from there. And then they should be looking up resources on the internet. And one of the resources that I'm going to mention right now, because I know about it, and I was just looking at it, there's going to be a link in the description. There was an NDC lecture about how not to do the containerization. Or how not to do microservices. And I think this is one of those things that you need to see. And then after you have read and saw all of those, then try to think about, do you need a container or not?
While being critical.
While being critical.
Okay, because two of the most common ways in which people do this, we're specifically talking about refactoring existing applications today. I'm not talking about developing the new ones, at least not yet. Maybe we might cover that today as well, or in a future episode. But there are two main ways in which people do that. They take a look at the list of services that that application has and then say, okay, we have 20 services. That means 20 containers. Developer 1, 2, 3, and 4. Each and every one of you is going to refactor 5 of those services in one container, or each and every one in separate containers and whatnot. Tell me when you're done. That's the first way. The second way is to take a little bit more monolithic approach and say, we're not talking about individual services. We're talking about, let's say, codependent services, sticking them inside one, let's say, container. And there can be a variety of different ways of doing
So
this.
modules, functional module, whatever.
Let's say instead of having 20 containers, we have 5.
Okay.
And then that's our monolithic applications, application sliced and diced into microservices. Both of these ways are wrong.
I think that both of these ways are usually wrong. Mm-hmm. They can be correct. But my biggest concern when I talk to somebody who is into containerization mm-hmm. is usually starting from the point of the container should be able to be deployed and destroyed at will. Mm-hmm. Is your application designed in such a way that I can deploy and destroy any part of your service if I leave at least one of them running, mm-hmm. and the application is going to run?
Yeah. Again, fundamental topic of design.
Yeah, and this is one of those things where almost all of the design fails.
Correct. Because
what the people usually do is they design container by container, function by function.
Correct.
And then they have no use of functions running concurrently. Mm-hmm. They have no idea of concurrence. Out of having no idea of concurrence, they have no idea of coherence. So they have no idea on how to keep the whole system working
in a stable state.
In stable state. Mm-hmm. And suddenly you lost the entirety of the benefits of containers. While at the same time adding complexity upon complexity upon complexity and adding additional CPU cycles. And this is the thing that we are trying to avoid, because we are trying to scale and we are trying to avoid doing unwanted work. Okay. And suddenly we are creating basically what could have been a single VM. We have created 20 containers out of it.
Let's say that by far the most containers that we have worldwide in production nowadays are being run for the purposes of running web applications.
Yes.
I think we agree on that. Which means that even if you look at the most common, let's say, types of applications, like, let's say, 2-tier, 3-tier application, whatnot, whatever you want to call them, you're going to run into additional complexity because of running things in containers that you didn't necessarily consider while you were planning your refactorization. For example, if I'm about to do, let's say, an open source application, which has, let's say, MySQL as a backend database, and it's running, for example, on, let's keep it super simple, on Apache web server. Let's say we have just those 2 tiers, database and the front-end web part. There is literally no person on the planet that is going to force me to run that MySQL in a container. Okay?
Okay.
There are multiple design-related reasons for that. And out of that comes a variety of different reasons why you shouldn't do it this way. I've came to this conclusion years ago in various projects that I used to do. In those use cases, if your end goal is to create an application that is highly available, which is most commonly the reason why we develop applications like this, that means that you have to have multiple front-end web servers running the web application while being connected to the backend database. If you want to load balance the database, that's a can of worms that you don't want to open, because that's highly complex, especially in MySQL. It's not exactly a straightforward thing.
Okay, but it's not a walk in the park even if using my Microsoft SQL. So
no. It's basically applied to any database. Yes. What I'm about to say, and I know that people will disagree, but yeah,
consistency is a witch.
Yeah, and learn your high availability systems for databases for a high performance environments. Then we'll talk. Okay. That's my kind of like the fence over which I'm not looking back into the schoolyard. I'm not going to go back to that school. Which means that the way in which you can run this application basically consists of whatever amount of containers for the front end and the database in cloud or in some kind of a monolithic big virtual machine. Most
Okay.
common thing.
Yes.
Usually in these use cases, I would select cloud, which means that I'm basically signing on the dotted line a contract at which somebody is going to be very expensive, because those things are very expensive, but still they offer less complexity in terms of the architecture of you having to deploy it and make it run fast up to certain SLA level, which is important, versus just having it there and putting your stuff in a database. And this is something that I mentioned over the course of the past, 10 years since I started doing work, for example, on Azure. Most people do tend to think about it this way, which again is a simplification of a known problem, which I agree with that approach. But here comes the problem that's actually real. You can have as many of your front-end containers as you want. So running your web application. You can easily configure those containers, for example, to serve the web content from, let's say, Azure, or AWS, GCP, whatever, cloud storage account from a share, or synchronize them in between them, which usually we don't want to necessarily do. We want to have some kind of a scalable and highly available approach to the storage of that as well, in a sense. Here's where things get much more complicated, because out of the box, most people doing the development of this are going to forget about the fact that some kind of a backend storage like this needs to exist. That's the first problem. And then on the front end, there's an additional problem because, and hence the reason why I was so adamant that some things in our DevOps episode were structured in a completely incorrect way in terms of the not necessarily complexity, but the order in which it was presented on that website.
Okay.
That means that you will have to figure out a way to load balance them as well. And that can be a part of your workflow or something that you do on a side.
Can I interrupt you?
Yes.
Because I think that you went way too far into design.
Yeah,
and
I did
the
it on
reason,
purpose.
No, okay, you did it on purpose, but I think that you made an absolutely phenomenal point, and then you went into design. I think that the biggest problem that we have right now is that people, when they're talking about containers, when they're talking about microservices, whatever, they're usually using the best possible usage cases as an example.
Like a marketing slogan.
As a marketing slogan. And then they're trying to fit whatever problem they actually have into the reality. And this is one of those things where you always need to come up with an example that is going to be an amazing example of why something should be done, but also there should be an amazing example of why something shouldn't be done.
Correct.
Because your example with microservices, cloud, SQL,
it was as simple as possible.
Yes, but this is the most usual example. It fits all the check marks. It is simple to understand. It is understandable by almost everybody who isn't a developer. It is actually scalable. It uses the technologies as they should be used. So there is no reason, from my perspective, there is no reason why we shouldn't be doing everything this way.
But
with a big asterisk, and this big asterisk is if everything is a thing that uses front end and the back end database, and that's it.
Yeah, which in real world doesn't have to be so.
Which doesn't happen.
Yeah, I wanted to start with something simple to kind of like, and then we can take a shovel and start shoveling.
And I think that the first thing that we should be dealing with is that, okay, you are dealing with a database, fine. You're dealing with front end, fine. Let's do it multi-area or multi-location, or let's do it across zones. As soon as you have something that has to run in the, I don't know,
multiple availability
zones, you suddenly have a big problem with the database. And then after that, you have a big problem with latency.
Correct.
And with concurrency, the concurrency is not such a problem, but the
database synchronization
is the biggest problem. And this is something that is going to bother you. And then suddenly you have a problem that you cannot solve by simply using microservices.
This is why I'm so heavily harping on the correct design principle, because it is easy to design this in a wrong way. And I'm to that point, cloud providers are kind of not necessarily on purpose, but they're making it easier for you to design it in a wrong way.
But I know, okay, I'm completely not with you. They're doing it on purpose.
I don't think they are.
Because I think they are. I think that the dark patterns and the idea of you piling up the resources is something that they quite like. So I think that one of the driving factors for the cloud providers is that they want to give you enough, the shovel big enough to pile the services on.
Yes.
And this
never
is,
to dig yourself out of them.
yes, and this is one of those things that you also need to address. But let's stop talking about the design like something that is okay, that is not happening, because as soon as you start creating your application, you're a designer. You're creating an architecture. So everything that you do is a design. It could be a better design, it could be a worse design, it could be an extremely bad design, but it's a design. So architecture is something that we are all creating. Let's talk about bad architecture and good architecture.
What I described, I would call basically a starting point of a good architecture.
I think that the example is an amazing architecture. But I think that then when you come, when the real life meets the design, then we are talking about things that should be and could be done better.
Okay. No. Actually, your basic way of approaching the problem that you just mentioned is to copy-paste my design across multiple availability zones, put load balancer in every one of those regions, availability zones, whatever you're using, and then to put a global load balancer on top of everything. This is by far the simplest solution.
The simplest wrong solution to the problem.
It's not wrong. It's not wrong per se. From the front-end application standpoint, it is a correct design.
Yes.
From the database standpoint, that's a different topic.
Yes, but I'm always talking about the system. I'm not going to be the one who is going to say, okay, I have an amazing system that has 12 different
locations,
parts. No, 12 different parts. 10 of them are amazing.
Yeah, that's called technical marketing 101.
Yes.
Yeah, okay. I actually wanted to go further with this, because this is where the part of design that a lot of people are not necessarily immune to, but unaware of, can come heavily into play. And you kind of touched on that by mentioning the word latency. Okay? Let's say that you're using, it doesn't really matter which cloud provider we are talking about. I'm just going to use Azure as an example because that's what I'm most familiar with. The latency between different regions, as you correctly started to point out, is different, which means jitter in our language of technical science. You can do database replication, or you can use a database as a service across multiple regions. So it's kind of solvable problem. But if you do it via VMs or something like that, then you're going to want to put basically that copy paste of the design that I mentioned. You're going to want to put the database locally in all of the aforementioned availability zones, regions, whatnot, close to the web applications at the front. And you're going to have to figure out the back-end way of replicating the data. This is where the problems that you mentioned not only start, they compound with huge interest. But there are actually a couple of relatively straightforward ways in terms of, again, the infrastructure part of design. This is not app design at all. If you know a little bit about, let's say, Azure in this use case that I'm mentioning, and if you configure your stuff correctly on the networking level, there are multiple different ways of those, let's say, VMs with MySQL communicating over front-end, back-end network, VPN. There are multiple different ways to connect this. There are pretty deterministic ways of measuring the latency, which is very important in this use case, not outright bandwidth. Outright bandwidth is important, but latency tends to be more.
Azure has an amazing bandwidth in dealing with VMs inside the Azure. You tested it.
I was going to go there. Yeah,
Yes.
He's being sarcastic, of course. Actually, what I found during the COVID era, it doesn't apply now, but what I found during the COVID era is that if I used a public IP address of virtual machine A and virtual machine B, and established, let's say, an SCP session between them, basically copying a large file, it was indescribably faster, not slower, faster,
yes, no.
than copying it via the backend network. Basically, the network within Azure that is not the public one, which really threw me. It shouldn't be that way necessarily, but it is what it is. But that's just one of the ways in which you can configure your stuff. Realistically, larger enterprises, if they're doing application as we are describing it, they would probably want to implement connections that are going to be akin to site VPNs, which is doable in Azure. And then you do have a lot of extra freedom, Azure gateways and whatnot, to select which size of the gateway you want, which is going to have direct influence on the latency and the bandwidth, guaranteed latency and the bandwidth, which is going to heavily improve your situation. So again, Excel IT management episode, cloud design is much more complex than a lot of people tend to think. But by making a series of good enough design decisions, because there is no ideal decision in this the scenario that we are discussing, you can get to a situation in which application works, I'm not going to say perfect because that's never going to happen, but well enough and is scalable.
Okay, but let's do a big step back and let's stop advertising cloud as something that is viable for scaling up applications, because right now we are trying to deal with monolith versus microservices.
Yeah, that's the next topic.
I think this should be the only topic, because if you go into how to divide those into cloud, how to do the multi-zone availability of
Next
the
step is
application, multi-cloud, and then trying to integrate private and public cloud, and then switching over to private cloud, and then switching over to Raspberry Pi that was actually able to run the entire application.
Then IoT and then whatnot.
No, but then deciding that there was a Raspberry Pi that was able to completely run the application, but we were just over-engineering everything for the last 2 years, and wasted a couple of $1 million on cloud services.
Exactly the reason why I started this story and went in that direction, because I wanted to further elaborate on the topic that we covered at the beginning of the episode, which is how to create a solution without a problem, or mostly create that scenario.
I just want to see, could it be possible to create a multi-million-dollar solution to do the Hello World web page in a cloud? And I know the problem is that I know probably at least 4 or 5 ways how to do it completely legitimately and without any meaning at all. So let's go back to microservices. Why should we do a microservices? And this is one thing. And then why should we do the even worse thing, management of microservices? K8s or Kubernetes and the other guys who are dealing with, I'm not going to go about the open guys who are dealing with the microservices. I'm just going with Kubernetes. Are today's developers over selling how Kubernetes and how microservices are working?
Yes.
When they are dealing things? And should we send the developers for a relearning process to make them
attitude adjustment
to make them stop misusing the services where they shouldn't be used?
You know how we talked a couple of months ago about laptops, and we mentioned Asus's laptops for a second?
Yes.
And we both use the terminology decrapify.
Yes.
That's what needs to happen.
But I think that the problem is that some developers are dealing with microservices in a way because...
I'm not talking about developers per se. I'm talking about the whole process.
Yes, but you cannot decrapify a process if the person who is designing the entire process doesn't think that it is crappy. And the problem is if you have a developer who only knows how to program microservice, he's going to program microservice.
Of course.
He doesn't understand how to step away and say, okay, this doesn't need to be 5 containers or 500 containers.
Hence the reason why DevOps is so important, and hence the reason why cloud engineers are just as important as the people doing the application programming.
But we cannot re-educate enough DevOps guys to become developers that are going to be fully fledged developers for the cloud.
We can if we look at them from the standpoint of system engineering and not from the perspective of programming, because both of these perspectives need to coexist within the realms of the same environment.
But to make a joke, and this is going to be a controversial one, you can create a good programmer out of a DevOps guy, but usually you cannot create a DevOps guy out of a programmer. So I think that the ops part is something
I think
that
you actually misspelled a couple of words, but okay.
Yes, I think the ops part is different from the dev part in such a way that in order to be a good guy in operations, you need a certain amount of being able to improvise and being able to understand new technologies. A good developer can be a good developer without understanding new technologies, just sticking to a single technology and being good at it.
Yeah.
And this is one of those things that is a big problem, because sometimes, and I mean a lot of times, you're going to run into a developer that is amazing at running a Clipper application, but he's not going to be able to do anything newer than this. As a side point, there is a Visual Flagship 8 for Linux that is able to run Clipper applications on the...
You really did check that?
Yes.
Okay.
I need to check the
textbook definition of insanity.
No. I wanted to check if I remember correctly. It is called the flagship. It is called flagship. It exists even now, and I bet you that we could do a container for this on Windows, and it would be able to run.
I have a couple of stupid ideas on that. That's awesome idea.
Okay,
I work for a company that's dealing with applications. They have more than a few Clipper and Borland Delphi based applications that we could containerize just for fun. Doing the wrong thing, of course, but still.
Yes,
for the purpose of having an exercise, nothing more.
Just as a side note, I'm waiting for when Microsoft is going to push for something that will be container-like. Right now, they have a big problem because they need a container.
We can run containers on Microsoft OSs.
Yes,
you
but
can run them in Azure in 3 or 4 different ways.
Yes, but I think that the biggest problem that Microsoft has is that they don't have their own solution that is container based.
Docker for desktop.
But it's not Microsoft.
They tried.
Yes, I know they tried. Because today I was just checking up. There is a new release of Windows 11 development suite. This is a VM containing Visual Studio and everything else required for development. And this actually tries to become a container, not a whole VM image. But they are unable to do it unless they're using a third-party solution, and they are unable to use a third-party solution. So this is something that should be containerized.
Okay, the good example of an app that needs to be containerized, unlike many others.
But I think that by embracing something like Snap or Flatpak on Windows, amazing things could be done.
You think that's ever going to happen?
Yes.
Okay.
There is Visual Subsystem for Linux, so it is going to happen there.
Yeah, I knew it that you're going to go that way.
But I think that we are going into the future where Visual Subsystem for Linux is going to be something that all the developers are going to be using.
Just like what they used to do with some other applications.
Yes, and this is something that is going to...
and whatnot.
Because the aforementioned Windows 11 development package with VM has installed Visual Subsystem for Linux. It is pinned on the taskbar, and it actually is fully functional as a Visual Subsystem for Linux. So they went so far as installing Linux inside the VM because the developers required it. So we have come to a point where something like containerization technology that is not proprietary, and it is not by a failing company, such as Docker, is going to be needed on Windows, and I would buy into it.
Ironically, the way in which Docker is failing is exactly because of the monolithic approach of Docker as a service to manage other services.
Yes. They completely missed the Kubernetes train. And this is one of those things when somebody creates an amazing technology and then
Realizes that the
completely misses the
architecture is
point.
completely wrong.
Completely misses the point.
Yeah, okay. But that's a good example, actually, of monoliths.
Docker is basically DOS.
Yeah. Metaphorically speaking.
Yes.
Yeah, I agree with that. Okay. The reason why I went with the approach that I took, so simple web application 2-tier, because 3 and 4-tier and whatnot tier tends to be much more complicated and complex. Specifically why I went with cloud, and I want to expand into multi-cloud and hybrid and whatnot, is to kind of describe the architecture as it gets much more complex, which is what we've partially done. But furthermore, to drill into a topic that I started talking about before I was so rudely interrupted, of course joking, which is load balancing.
Okay.
This is one of the biggest blind spots of developers from my standpoint that I've seen on the market so far. Because, and this is actually more of a global critique of the state of IT in general than necessarily just developers. People have a tendency to oversimplify, super oversimplify.
Or over-design.
Or over-design.
Yes.
But they oversimplify the way in which load balancing works in these sorts of scenarios. Okay? Because the correct architecture to do in these sorts of scenarios would actually be at least multi-cloud, some kind of a global load balancing solution, which is in completely different cloud to when compared to Azure, let's say AWS, with load balancing per site in Azure and VMs there. And then we can also start the discussion about having maybe parts of that infrastructure in AWS or GCP or local or any combination thereof. For a reason why I'm saying this, again, from design standpoint, is that is the design that alleviates risk. Very important aspect of these sorts of designs. And a lot of times, yet again, to further drive that point home, when people are dealing with the ops part of the story, they completely miss the point of it. What I just said is the point of that.
I think that first thing that people should have on their mind is that even the biggest cloud providers, when it comes to monitoring, are in multi-cloud. Mm-hmm. So Azure does its own monitoring through other providers' clouds because they have to. Mm-hmm. And it's the same with Google, it's the same with AWS. And this is where people should start learning about being cloud agnostic, being Correct. Technology agnostic, because sometimes the only solution is not to use the technology that you want to use, but it is to use the technology that you actually need to use. So wanting and needing something is not the same.
Well, cloud is definitely guilty of that.
Yes, cloud is always guilty of that. But what I want you to answer me is how do we bridge the problem between the architecture being done right using microservices and the developers understanding where and when they should stop deploying microservices and go back to the monolith?
That's a very good question. I don't see a single way to do that. Part of it is going to be, just like you started saying, re-education about some things, definitely. But my kind of gut feeling is that that's going to be very difficult unless we start teaching a lot of Excel IT managers and developers much more fundamental IT concepts for which they're not necessarily going to like that or take it. And I understand that. I'm not dissing on this. Because most time people who are system engineers want to do system engineering jobs, programmers want to do programming jobs. And this mishmash of things that happens in DevOps, containers are the fundamental highway of DevOps for the most part, is not necessarily something that everybody likes. But a lot of people use it because it's for their benefit until it's not. Just like when we talked about some other topics in some of the previous episodes, people tend to be very utilitarian about that. And I'm telling you, the second developers start realizing how much more complex the ops part of the story is, The second they're going to say, I'm here to develop. That's it. And everybody else, go solve. That's my experience. And I'm not saying that that's necessarily a bad thing or something that puts bad onus on developers, just so we are clear.
But I think this is a bad thing in the same way where people are trying to be in any work. So in any possible line of work, when you see somebody who says that he's going to just do did A or this one thing, and he's not interested, and he doesn't want to do B, C, or D. This is a person that you don't want to have any.
Generally speaking, in your team, yes, I know.
Yes,
but people have the freedom of choice. That's what happened with the market in the past 3 to 5 years, especially with COVID, especially with developers. It's not necessarily something that's going to last forever, of course. But if they see that situation and they want to just do A, and you force them to do B, C, and D, they're going to resign and find another job. I'm not saying also that that's bad. That's actually good for both sides. For the argument that you just made and for the developers as well.
Because from my perspective, dealing with microservices is usually messy. The usual thing that I have the problem with microservices is that microservices being completely misdesigned, being overly designed, and then having no documentation.
In wrong places.
In wrong places, and then having no documentation.
Of course.
And everything, this all combines into something that is almost completely non-supportable. And then when I come to think about microservices, I have yet to find a well-designed system that required my help. Usually, when I had to help somebody, it was somebody who completely did a complete screw up of the entire system, and then they required immediate help, and this help was usually something that was annoying, boring, and extremely tedious to do, simply because the system itself was misdesigned. So I think that one of the biggest problems from my perspective, from an ops perspective, is that usually when we have to deal with microservices, they're misdesigned. And if they're designed in a good way, they're usually designed by somebody who knows what he's doing, and then he doesn't need help. So suddenly, I see that the biggest problem for the ops guys is that they're always running into misdesigned systems, and developers.
That's my experience as well.
Yes, and the developers are always designing systems and then calling for help, which means that they are not doing their job extremely well.
I agree, definitely agree. We have a lot of, let's say, statistical data to prove that point, actually, already here in our work, so not going overly deeply into that, but for some reason, our students that are on the program engineering program, most of them somehow think that the containers are be-all-and-all solution for their problems, which they're not.
Okay, but this is in line with the people who see the technology X being the Angular, Node.js, whatever is the solution to end solutions, and that's it. And these are the people.
It's understandable that they are like that until their head gets smashed into the wall of fixing a problem which they cannot fix with a certain technology that they kind of like think that they're going to fix it with. It requires real life experience.
Okay, but this is something that also requires a lot of work.
Of course.
It requires a lot of self-work. And this is something that a lot of people, when dealing, right now we are talking about education, dealing with microservices, dealing with technologies such as Kubernetes, Dockers, Podmans, OpenShift, and so on and so on and so on, requires you to understand an enormous amount of topics.
As we discussed in the DevOps episode.
Yes. And it's not only that you need to understand the enormous amount of topics, you need to actually understand them.
Yeah.
You cannot just know about them and then work.
I heard about that. That's
and I can work my way around it, because as soon as you start working your way around a particular piece of technology in the Kubernetes world, you're going to end up in a big trouble.
Yeah, I agree.
And this is something that is usually missing from the perspective of the dev guys, and I'm sad about those because I think that they are just misplacing or not understanding the complexity of the problem that
They're
faced with.
misapplying things in a lot of different ways.
Yes, but I think they're missing the complexity. I think that the problem that we created with all the microservices is that at first glance, all of them seem simple.
They're not.
Yes, but they seem simple.
Yeah, I know.
When I try to explain to somebody what a Docker is, you just said, okay, it is a smaller VM that is able to do its own job. It is an amazing thing. It has Union FS, whatever. And then suddenly you realize that the person does not grasp the concept of what you're trying to say and doesn't understand that as soon as you start adding layers, and you are adding layers, you are suddenly going to end up with something much more complex than they're able to.
And something that they can touch
grasp.
less, basically.
Yes.
Because it requires a little bit of imagination to understand how those objects work as well, which not everybody has.
I think that the biggest problem that I have seen when dealing with containers is the idea of not being able to have something that is going to be permanent. And
Okay.
the biggest jump for every designer or every developer, the biggest jump for every designer or every developer is jumping from I have my database inside my VM, I have my web pages inside my VM, I can do whatever I want to cache it on the VM's disk and then do exceptional Z. And then jumping to I have my container, I cannot put anything into the container and consider it permanent because it is going to get erased. And when they realized how to do this, they are more than halfway there.
Agreed.
And this is one of those problems.
Hence the reason why in my example of the design, I was talking about storage account and some kind of a file share for mounting the data for the web application instead of copying the data into the container itself, because that tends to be the wrong approach in many of the use cases. But to kind of like come back to the original topic, or to circle back to the original topic, what do monoliths have to do with all of that? Going back basically to your first question, why do we need containers? Do we need them at all? And when?
I think that the biggest thing that we need to realize is that do we need Linux?
Yes, we do.
Why?
Because it works.
So we need a monolith because it works sometimes. We need Windows because they sometimes work. We need cloud because it sometimes works. So it's just a tool. I think that being a monolith or being a microservice-oriented or a serverless-oriented service is something that is just up to the designer. It gives you
And application.
It gives you the ability to have a larger tool set to solve problems, but it's not a end-all, save-all thing. So we cannot fix all the problems by using any of those services.
Courses for courses.
Yes, but so monolith is a monolith. Serverless is serverless, whatever. We can use, and I know a particular case that was using serverless functions in the right way 10 or 12 years ago, because they just realized that this is a solution for them. They were using this solution for a particular, extremely particular case, but it was working amazing for them. And the rest of the application was in a monolith as they come. So it was without any other outside dependencies, without any outside calling of any outside functions, and it was a big monolith. The application itself was a couple of gigabytes big. So basically, it used the serverless functions, Lambda functions, for a particular case that they needed to solve, and the rest was the monolith. And it was an amazingly designed application because it served the purpose. And I think that, do we need a monolith? Yes. Do we need the serverless applications? Yes. Containers? Yes. OpenShift, OpenStack, VMware? Yes. Because they all serve
tools.
a purpose. They're tools.
As long as we treat them as tools, we're happy with the way in which they might be used. Let's call it that way.
Yes, and this is one of those things where people are unhappy when I say that the reason why I don't like macOS or Apple is because they refuse to be part of any toolset. They intentionally are not trying to be compatible with anything because they think that their ecosystem is good enough to be self-sufficient, self-sustained. And this
They've
is
been right so far. For them, at least.
Yes, for them. But I think that one of the problems is that I want to be able to use macOS as one of the tools. I want all of my hardware and all of my software to be able to work together. And this is the reason why sometimes I don't like Apple.
Okay, so how is your transition back to Android phone going?
I'm going to switch over in the end of the month, but I'm quite happy. I think that the only thing that my iOS taught me is that it's an amazing design system. Inside, it works amazing. It is running much better on much worse hardware than the Android is. At the same time, it lacks some functionality. But I in the last half year, I didn't miss almost anything other than wireless support. Okay, wireless support is flaky. But by my wireless support, I mean things that shouldn't be supported at all on the mobile phone. So like something like Wiresharks and so on. And this is the only thing. The only thing that I'm actually annoyed by is that in order to get a phone that is running correctly, you must spend at least 3 or 4 times more than on a given Android phone.
To have your apps or what?
Yes.
Replacement apps or
yes.
Whatnot.
So I think that this phone is old. It works great. It is amazing for its hardware capabilities, but it is not different enough from the Android world that it makes me happy. And I have almost all my stuff in the Android world, so I'm not dissatisfied with the iPhone.
Why do you need to be happy with the phone?
Because I'm using it. It's the device that I'm most using during the day. I want to be happy with the screen. I want to be happy with everything that is working on the phone because this is the only thing that I'm using all the day.
Okay.
It's like having a bad tooth. You don't have to have a bad tooth, but since you are using it all the day, you are going to notice it every day, all day. So you need to fix it.
Okay.
And this is just like a misplaced. But while using iOS, I just feel like I'm using wrong shoes. So everything is okay. They're my size, but
something is still awkward.
Something is awkward, yes. And I'm missing some things. And I see that if I want to buy better shoes by Apple, I'm going to be wasting enormous amount of money. So
just like you would in cloud if you overdo your
yes.
redesign.
But it's the same. It's the same with all the services. So this is a tool, but this tool is not connected enough to the rest of my tool set, and this was my primary point. And by itself, it's amazing.
But in your ecosystem, it's an outlier.
It's an outlier, and it is something that I cannot connect to a couple of devices that I would like to connect to.
In my metaphor, the cost of the cloud environment for running stuff like apps and whatnot is very akin to what Apple.
Yes, no. This is one of those things.
Yeah, it is.
Okay.
For the time being, that's enough. We're going to have some future episodes related to this topic.
Yes.
Scratch the surface of monoliths versus containerized applications.
And iOS versus Android.
Yes. There are many more topics to cover, but we're going to leave that for some future episodes. And until then, I've been Vedran.
Thank you for being with us. I was Jasmin. And see you next time.
Bye.
Bye.